Guys, in this video I'm going to explain why a stronger boat isn't always the best option. As we know, boats are made to fix some part to the other, some piece to the other. So let's assume that you are assembling something and you need a boat to fix these parts. So you go to the store and you find some option of boats. You find the thread is the same that you need to use, the head is the same, and the length is the same. The only thing that's different is the material. So you have basically some types of material that you can use. Let's say that you find grade 1, like this chart here. Grade 1, there's no mark on the head of the boat, and perhaps there are some numbers like 4.6. Grade 2, there are no marks and the number is 5.8. Grade 5, there are 3 marks and the number is 8.8. Grade 8, there are 6 marks and the number is 10.9. But then you are stuck what those numbers mean or those marks. You can find either marks or numbers. So basically, the stronger the boat, the higher the number. So here's the least stronger boat, here's the most stronger boat. Let's take this 5.8 boat as an example. The number 5 represents the maximum force that the boat can hold before it starts to necking and suddenly breaks. The number 8 represents the maximum force that the boat can handle, stretching and returning to its original state unharmed. In this stress-strain generic chart, we can see here in the y-axis we have the stress. It's the force that the boat can hold. Here in the x-axis we have the strain. Is how much the boat are bending or deforming. So in this green region we have the elastic region where the boat can stretch and return in its original shape unharmed. If you pass this yield strength region here, the boat enters in this plastic region where the boat can deform and doesn't return in its original shape. So basically, if you tighten too much the boat, it can stretch so much that it can break. If you do the math in this grade 2 boat as an example, the number 5 represents 500 megapascal. The number 8 represents 8% of this 500 megapascal. So 500 times 8% represents 400 megapascal. To use the size of the boat in millimeters, we need to convert this megapascal to millimeters. So converting, we have 400 Newton divided by millimeters squared. We're gonna use this number later. Let's take a 12 millimeters boat as an example. However, this 12 millimeters thread is the size of the external part of the thread. To calculate the force that this boat can handle, we need the inside of the thread. So the 12 millimeters boat has 1.75 pitch, which is one peak of the thread to the other. So 12 millimeters minus 1.75, we get 10.25. This is the number that we're gonna use to calculate the force that this boat can handle. To find the force, we're gonna use this formula here, which is force is equal to pressure times area. The pressure we already have here in this example, which is the 5.8 or grade 2 boat. and the area is pi times radius squared. So the force is 400 times pi times 5.125, which is the radius of 10.25. It's the half of the size. So the results that this boat can handle is 3.37 tons. After you pass 3.37 tons, which is this region here, the boat starts to stretch and can break very shortly. If you do the math for this grade 5 8.8 boat, the results are 5.38 tons. For this grade 8 10.9 boat, the results are 7.57 tons. But wait a minute, why they just don't get rid of these weaker boats and produce only these stronger boats that can handle so much more force? Short answer is vibration. Everything that's fixed with a boat can be a table, a bicycle, a piece of a part of your car, has some vibration in some degree. Let's go to the workshop and I'll show you what I mean. Okay guys, we are on the workshop. Here we can see this bolt is used to fix this part here. But this machine, when it's in use, it vibrates a lot. So here we have this bolt which is 5.8. If we put a stronger bolt here, the vibration is gonna make the bolt come loose. So here we are using this less stronger bolt. In the past, maybe someone used a stronger bolt here, but as you can see, the stronger bolt you need to tighten too much to make this part be fixed. So if you tighten too much, you can break the table like this. In this other table, we are seeing a bolt that is stronger. If we put a weaker bolt here, the head is gonna break. So here we have an 8.8 bolt, which is stronger than this one. Here we can see some examples. 5.8 bolt, 8.8 bolt, 10.9 bolt, 12.9 bolt. These bolts are different in shape and size, but I'm only showing some examples of different materials. So you keep an eye on it. If the bolt is coming loose, you can use a weaker bolt. If a bolt is breaking, you can use a stronger bolt. That's it for this video. I hope you enjoy it.